During the second module, we're in the process of dealing with nuclear physics and its applications. We have underlined several times that the basics of the nuclear force in terms of quantum chromodynamics are anything but clear. The purpose of this optional interlude is to trigger a discussion on this particular subject. The relation between the nuclear force, which binds together nucleons inside the nucleus, and the strong force, which binds quarks to form hadrons, is not clear at all, although the two must be obviously related. In fact, the nuclear force ought to be a long-range effect of QCD, binding nucleons via color-neutral objects. An interesting discussion is found in this article by one of the fathers of QCD, Fred Wilczek, in the journal Nature. The source is quoted on the top of this slide. An accessible summary can be found on the web at the address quoted on the bottom, and here is a short excerpt that I will read to you. Ironically, from the perspective of QCD, the foundations of nuclear physics appear distinctively unsound. He continues by explaining what the contradiction is. Yet QCD tells us that protons and neutrons are themselves built from quarks and gluons that move at very nearly the speed of light. These more basic particles carry color charge, leading to the additional requirement that they be confined within bags whose contents are overall color neutral. And he further asks, but why don't the separate proton and neutron bags in a complex nucleus merge into a common bag? On the face of it, the one-bag arrangement has a lot going for it. It would allow quarks and gluons free access to a larger volume of space and so save on the energy cost of localizing their quantum mechanical wave function. But in such a merger, protons and neutrons would lose their individual identities, and our traditional, quite successful model of atomic nuclei would crumble. What prevents that calamity? I invite you to think about this question yourself and discuss it in the forum of this course. We will come back to it in Module 5, which will deal with hadrons and their strong interactions.